Question 5.6. We want the values of x for which f of x times the derivative of g of x, so it's g prime x, has to be greater than or equal to 0. So it will only be the case if both f of x and g prime of x have the same sign. So either both can be positive or both can be negative. But if you look at the gradient of g, it's going to be negative because this hyperbola is decreasing because it's simply drawn in quadrants 1 and 3. So for any x value, except of course for the asymptote, g prime of x is going to be negative. Okay, the gradient is going to be decreasing. So all we have to do is look at the second solution, and for the product to be positive, which is what you want, it simply means f of x has to be negative. So we simply have to look for where the graph of f dips below the x-axis. So all we have to find is, we have to find the x-intercepts, and that can be easily done by setting y equal to 0. So remember the equation of f of x is f of x is equal to negative x squared plus 4x minus 3. And if I want to find the x-intercepts, I'm going to let y be 0. So 0 is equal to negative x squared plus 4x minus 3. If I multiply both sides by negative 1 or change the sign, we're going to get x squared minus 4x plus 3 is equal to 0. And if I factorize this into its two factors, it's going to be x minus 3 and x minus 1 is equal to 0. So your critical values are x is equal to 3 or x is equal to 1. So here on the diagram, this will be the bigger x value, so that should be 3. And here the x value should be 1. And recall, we want f of x to be negative, so that's going to happen on the right of 3 and on the left of 1. So you could write your solutions as x is greater than or equal to 3, since you're including, or x is less than or equal to 1.